Hi, I'm Nidhi Singhai. I'm from India Internet section. I'm going to give demo about the programming project that I have implemented. I have chosen two programming assignments for implementation. The first one is the implementation of classical ciphers, which includes substitution, transposition, and product cipher. And the second one is the implementation of RSA crypto system. So, the first, let's start with the classical ciphers. I'll just yeah, that's my executable. So the moment we start the program, it takes us to the first page, which is to enter a choice. Now, if we just look at the uh, files that we have for the input, the way I have organized my files is I have kept all the input files or the key files into another folder. So here we have four input files, two for 1 KB and one for 2 KB, the other one for 5 KB. I have a substitution key, a transposition key, and a sample file. Now, if we just look at the substitution key has a conversion rule for each input character set. So that is the small alphabets, the capital alphabets, and the digits. And if you just see the transposition key size is equal to the block size, which is 8 characters. And I have taken a string or a word as the input. So this will be converted into corresponding positions for the transposition. So now we start with our encryption. So we'll first encrypt a 1 KB file using substitution. We'll encrypt the 2 KB file using transposition and the 5 KB using product. So first I choose encrypt a file. I choose the substitution cipher, file star input1.txt, ski.txt. Yeah, now it shows that the location, the retrieving, first it does is retrieves the substitution key, performs encryption using substitution, and the location of the substitution cipher file. So it's in subcipher.txt. So if we just check this, we have it here. Now we'll just check. So this is the substitution file that we have, the cipher file. Now we'll decrypt the same file. Let's first check what the original file was. Original file was this. Let's just decrypt this file. Oh, sorry. It takes the input as the cipher file and the key file, and the output is a plain text file which is present in location file subsplain.txt. If we again do, we have it here. If you'll just see, the size of the file is the same as the input file. And yes, we have our decrypted plain file. Now let's use transposition cipher on the other file. Our second sample file is input2.txt. This is our second sample file. So we'll perform the transposition cipher. Our transposition encrypted file is located at files transcipher.txt. So let us just check transcipher.txt of the same size again. This is the transposition. The transposition rule that we have chosen is the row transposition rule. So we pick every, since the block size is 8 characters, so we pick every 8 characters and use this transposition key, which forms our transposition rule, and shuffle or permute the characters in that block and write it to our transposition file. Now, if we choose decrypt, ciphertext takes the input as ciphertext, takes the input as the key file, and my decrypted file is present at files transstorage.c. We'll just check it here, and yes, it is here with the same size. So this is my decrypted file that I have got. Now let us perform using product cipher. Now we'll pick up the 5 KB file. Let's just check its contents. These are the contents of the 5 KB file. We encrypt the file using product cipher, file /input 5.txt. File, it takes the substitution key as input, it takes the transposition key as input, and my final encrypted file using product cipher is at location prod_cipher.txt. And we have it here. Subcipher is the intermediate file that we have, that we use during using encryption. Prod cipher. So first we performed substitution and then we performed transposition. Now we use decryption on the same file. So oh sorry, I chose transposition cipher here. Okay, let's see what it does. Transorage. This was not what we intended, but I'm sure this will again be an encrypted file. Yes, this is encrypted by substitution now. Let us instead decrypt our file using product. So the file name is file. The substitution key, file sat subs key.txt, trans key.txt. So we have it at files prod_text.txt, which is here. This is a file that we have got. Now the last part is cryptanalysis. In our case, I have used the transposition cipher cryptanalysis tool here. Substitution cipher and product cipher will be taken up as future work. So if we use transposition cipher file, which is transcipher.txt, sample words file. Now we'll just check the sample file here. It contains boarding, computer, and security. Now boarding is a word which is not present in my input file. So it will first search for boarding. Since it will not find boarding, it will go to computer. Computer is present, but in case computer was not present, it would have gone to the third one. But since computer is present, we should be able to find it. Second, it will also look for the cases. Like suppose computer has a capital caps word. So it will look for the caps and small letter as well. So my sample words file is sample.txt. So if we just look at this, analyzing transposition cipher, the sample words are boarding, computer, and security. We're trying to find the transposition key first. The sample word picked up for analysis is boarding. Sample word picked up for analysis second is computer. It has found the transposition key, which is 50231476. It writes the key to the key file. Then it decrypts the file using the transposition key. Now our key file is present as transcript key.txt and plain text is transcript plain.txt. So if we just look at these, this is the transposition key that we have, and it corresponds to the jumbled words of rainbow. Then we have transcript plain. This is the decrypted file that we got from that. So this brings us to the end of our first programming assignment. Now we'll do the demo. I'll do the demo for the RSA project. Now again, my RSA is the way it is structured is I have another folder as files, and it contains the input files. So this input text is 1 KB, and this is just a general text. So for RSA, the first requirement is to generate the keys. So what we do is we have three executables in RSA. One is for generating the keys. Generate keys generates the keys and stores them into different files. Then we have encrypt message, which takes the input as the plain text and the public key as the input key file. Then decrypt message, which takes the uh, encrypted cipher file as input and the private key as the key file. So we'll first do generate keys. We can use, right now we have used generate keys with no parameter. If I use it with parameter, my debugging will be turned on. I can turn on the debugging with that. Here we are trying to find the random numbers. The way we are generating random numbers is I've not used the GMP random number generator because the random number generator of GMP uses linear congruential method, which is not advisable. So what I have done is I have used the rand and srand of C, and I have concatenated 16 random numbers into a string. That string I have converted into a GMP number. So the multiprecision library that I'm using here is GMP. So I use that as input, and I've created a random delay of approximately 1 second between each run so that I don't get the same number repetition here. The best time that I have got for generating a prime number, see we have got P here. Now we'll generate Q. The best time that I have got is around 26 seconds, and worst has gone till 10 minutes. once we generate both the prime numbers, the prime numbers have been generated using the Miller-Rabin method, and Miller-Rabin, we know, produces a number which is highly probably prime. So what I do is I check these numbers that I have received with the GMP inbuilt prime number function. So, and I just verify the output. That is just like a verification that I do, and it returns me that yeah, both of the numbers are most probably prime numbers. This is taking quite long. Great. So we have the prime number generated. So as expected, the time took around 444 seconds. Now P and Q are generated. We verify the primality of P and Q using the inbuilt GMP function. So it returns us that P is most probably a prime number, Q is most probably also a prime number. Then we calculate our encryption key using this. So the function that we have used here is GCD, is self-written GCD function. And then we have calculated the decryption key. For calculating the decryption key, we have written a function to calculate the inverse of encryption key using extended Euclidean method. So we copy the private key to the private key.txt and public key to public key.txt. So we'll just check these files. We have private key.txt and public key.txt. So private key.txt contains N and D, and public key.txt contains N and E. Now we'll use both of them for our encryption. Now to encrypt the message, we use the binary encrypt message. Now we enter the plain text file, which is input.txt. Yes, input.txt. We enter the public key file, which is public key.txt. The location of our cipher file is RSA ciphertext.txt and the time taken is 26 milliseconds. Now we'll just spend a couple of minutes on our ciphertext file and the way it is written. Now the ciphertext file, it contains the message. How we do the encryption is we read in 32 characters, we convert it into a GMP number, we perform the encryption on that, and then the encrypted number is copied to uh, the ciphertext file. Now since the text file is huge, we separate consecutive numbers by a space. Now, just to maintain the compatibility between the input character set and the output character set, what I've done is I have just changed the alphabets I've just changed the digits to alphabets. So our A corresponds to 0 while our J corresponds to 9. So that's how this ciphertext is made. Now, next we'll do the decryption, RSA decryption. So we'll do decrypt message. Our ciphertext file name is RSA ciphertext.txt. Private key file is private key.txt. And the location of the decrypted file is RSA plaintext.txt, and the time taken for generation of keys is 32 milliseconds. If we just check here, we have this RSA plaintext.txt, which gives us the corresponding file. So with this, we come to the end of the demo for RSA as well. Thank you. In case of any questions, please mail me at nsinghai@hawk.iit.edu. Thank you.